So today we're going to be talking about variables and expressions. So what is a variable? Well, a variable is symbols that used to represent numbers. What symbols can we use? Well, we can use numbers, variables, well not numbers, sorry, variables, such as letters. Probably some good letters to avoid, remember, would be letters like 0, maybe a T, certain ones. You can also use symbols such as triangles or things like that. An algebraic expression, then, is one or more numbers and variables with at least one arithmetic, which means add, subtract, multiply, and divide operations. So you're adding or subtracting or doing something with these, but one or more numbers and variables being used in the problem. These words I hope we know, so if you don't know these already, you need to learn them. Sum means add, difference means subtract, product means multiply, and quotient means divide. So I do expect you to know those words, so when I say find the difference, you don't have an idea of what that means, you should know that. Alright, so what does 4 to the third power equal? Well, first thing we know is that it means 4 times 4 times 4. 4 times 4 is 16, 16 times 4 is 64, so that's equal to 64. This is called exponent form, 4 to the third power. This is called factor form, and then this is called the answer. This next part, I'm not really sure why the answer already ended up here. I tried to get rid of it and couldn't. But write an expression for these words. Products, that means we're going to multiply. 7 and then m to the fifth power. So there it is. Usually we don't use the x for times anymore, and I usually don't even put a dot in between numbers and variables. So that would be the product of 7 and m to the fifth power. Again, how about if we wanted to find the difference? Well, we know that means subtract of 4 and x squared. So the difference means we're going to subtract 4 and then x squared. A special way to say squared is to the second power. A special way to say the second power. What's a special way to say to the third power? Something cubed. So x cubed would be x to the third power. 5 less than a number c. This is really important. A lot of people get this mixed up. If you write 5 minus c, that is going to be wrong. 5 less than a number, you need the number first, so you can have 5 less than it. So it would be c minus 5 is what you need on that one. Let's see if we can go on to the next slide. Doesn't want to seem to go on. There we go. This is just some practicing some computation. We need to know how to do that. So it's the rule when we add and subtract decimals, remember, we line up our decimal point. So if I'm going to write this over here, 6.8 and then 24.95 would go underneath there. Then I can add, that's 5, 9 plus 8 is 17. Remember, carry your 1 in the next column. 10 plus 1 is 11. Carry your 1. Bring the decimal straight down. So 31.75. Here we're subtracting. Where is the decimal in 9? It's at the back of the number. So I need to still line it up like this. Put the 0 here. I got to come over here and borrow. 10 minus 6 is 4. And then 8 minus 2 is 6. Bring the decimal straight down. When we multiply, we do not need to line up our decimal points. You can, but it really makes more work. So just think of this as 23 times 17. And then multiply. 7 times 3 is 21. Carry your 2. 14 plus 2 would be 16. When we start multiplying by our next number, remember we have to indent. Some people put a 0 here. I just usually leave it blank. But 1 times 3 is 3. 1 times 2 is 2. Now we add. And now we say, how many places do we have to the left of the decimal? Well, we have 3, or sorry, to the right of the decimal, we have 3. Starting at the back, we count over 1, 2, 3, and my decimal point would go right there. Okay, I'll put that room here to do this. 25.2 divided by, so the 25.2 goes in the inside, 0.12 goes in the outside. Well, we really can't divide by a decimal, so we're going to change it to a whole number, which means we either multiply by 100, move the decimal over 2. So if we move the decimal on the outside over, we also have to move it over on the inside the same number. Then we bring it straight up, and then we start dividing. 12 goes into 25 2 times. That's 24. Subtract, we get a 12. 12 goes into 12 once. Now, even though we have no more numbers, we do have to fill in the space between the 0, or between the 1 and the decimal with a 0. So 210 would actually be the answer to that. Well, maybe we can get on to the next slide. Here we go. Fractions. Adding and subtracting fractions, you must have a common denominator. They have to have the same number on the bottom. So what will 4 and 5 both go into? They both go into 20. You can always find a common denominator by multiplying the two. Another way to do it is take your biggest denominator and look at multiples, like count by 5s, 5, 10, 15, 20, until you find something. So we want to change 1/4 into so many 20s. So we ask ourselves, what do we do to 4 to get this 20? We multiply it by 5. So if we do something to the bottom of a fraction, we've got to do the same thing to the top to keep it equal. Here, what do we do to 5 to get 20? We multiply by 4, so we must do the same thing to the numerator up here. 4 times 3 is 12. Now we can add and we get 17/20. Subtracting, again, you also must have a common denominator. So 8 times 3 is 24. That happens to be the smallest common denominator. What do you do to 8 to get 24? You multiply it by 3, so 3 times 5 is 15. What do you do to 3 to get 24? You multiply by 8. 8 times 1 is 8. Now they have the same denominator. You may subtract the numerators, 7/24. Okay, I'm going to go ahead and do my other addition problem down here. I can change this one here into 9, so I don't have to worry about the first one. So that would be 3/9. 4/9 plus 3/9 would be 7/9. Here I'm multiplying. I do not have to have a common denominator. You can cancel any numerator with any denominator. So I'm going to divide the 2 and 10 both by 2. 2 goes into 2 once, 2 goes into 10 5 times. Now I'm going to divide the 3 and 9 by 3. 3 goes into 3 once, 3 goes into 9 3 times. Now I'm going to multiply my numerators. 1 times 3 is 3. Multiply my denominators. Always look to see if it is in lowest terms, because if it's not, that meant you didn't finish the problem.